Hey guys, welcome to the lecture on probability distributions. This is your first lecture on this topic. So in this lecture, I'll be covering random variables, specifically the discrete random variables and continuous random variables. So let's start. What exactly is a random variable? A random variable is a quantity whose value depends on a chance. So yeah, let me write this down here for you. Let me change the color. So quantity whose value depends on chance. So a random variable again is a quantity whose value depends on a chance. We usually denote random variables by capital letters. So like capital X, B, M, T, anything. So you can denote random variable by any capital letter. So let's say this X here is let's just take some examples of random variables. Let's say this X is a number of sixes, the number of sixes obtained when a dice is rolled 3 times. Obtained when dice rolled 3 times. Okay, so that's X, capital X. Let's say what capital B is. It's the number of babies in a pregnancy. So I'm just gonna write it short here. Number of babies in pregnancy. Okay, you can have 1 baby, you can have 2 babies, you can have twins, which is 2 or whatever. You can have 3 babies, right? So pregnancy. What is capital M? Let's say it's a mass of chips in a pack. Mass of chips in a bag, let's say. Okay. T. So let's say T is a time taken for a runner or a sprinter to complete 100 meters. So this is time taken by a runner. All right. So again, random variables are denoted by capital letters. As you can see, X, B, M, T, they're all capital. X is number of sixes obtained when dice is rolled 3 times. B is number of babies in pregnancy. M is mass of chips in a bag, and capital T is time taken by a runner. So the X and B here, as you can see, the X and B have a finite or countable number of possible values. So number of sixes can be, if we take an example of X, you can get 1 6, you can get 2 sixes, you can get all 3 sixes when the dice is rolled 3 times, right? For number of babies, again, it's a countable value. It can be 1 baby, 2 babies, 3 babies, right? For M and T, though, they are continuous variables. What I mean by that is you can have a mass of chips in a bag, right? So you can have 53.56 gram chips in a bag, right? So the mass can vary. It can be a continuous value. It can be a 63.569, some random value. So it's not a discrete value. It's not 1, 2, 3, 4, 5. It's actually a continuous value. Time taken by a runner, right? When someone is sprinting for Olympics, it's not an exact value. It's not like 5 seconds, not 7 seconds, not 8 seconds. It's something like 9.76526, right? Some weird number like that. It's a very continuous variable. A runner might take 5.9789 seconds to run 10 meters, for example. So these are not strict values. These are continuous values. They can take any value they want, right? So that's why M and T here, they are a type of, change the color, they're the type of continuous random variables. All right, and these guys here, they have finite or countable number of possible values, right? So that's why these guys here are discrete random variables. So again, to recap, discrete random variables, these have a finite or countable number of possible values. Continuous random variables, these can take on any value in some interval. So again, number of babies in pregnancy, 1 or 2 or whatever, right? They are all countable, finite values. A runner that's running on a track in Olympics can take values like 5.5697 seconds, right? Any value they can take for continuous variables. So yeah, so that's pretty much it, guys, as far as difference between random and continuous random variables are concerned. I'll see you in the next lecture of probability distributions. Thanks for watching.